The Kokomo Model. Now, what is this Coco? What for this Coco model is used for any project, mainly the software projects we are talking. So it is always before the project management can even start or project planning can start. We need to know how much cost this project is going to take. What is the time it will take to complete and how many people, that is the effort that is to be employed. So Barry Boehm, he introduced software estimation models bearing the name Cocomo. And this Cocomo has come from COnstructive. First CO has come from COnstructive. Second CO has come from cost. And MO has come from model, constructive cost model. Originally, when this Kokomo model came, 1981 it came, and it became a hit. It was widely used, and then because of changes in the software technology environment, it has evolved into more comprehensive estimation model, Kokomo 2. So Kokomo 2 is a hierarchy of estimation model addressing different stages of the software process. Whether you take waterfall, spiral, these are SDLCs I am talking about. So Kokomo 2 models requires input as what? Sizing information, and that is the size, line of codes or function points, etc. So these are sizing option. It can be the object points, it can be the function points, function point analysis we have already seen, and the line of source code. Now we also call it as the DSI, that is delivered source instruction. Kokomo 2 is 1995 extension to the earlier Kokomo 1981 model that incorporates various other things like the object oriented paradigm orientation, modern life cycle models, the rapid prototyping which has come, the agile kind of development has taken place, the rapid prototyping, the different languages which has come up, 4th generation languages, and the component of the shelf or the Scotch software. So there are 3 forms of the Kokomo. There are 3 forms because the project can be different. It can be basic, it can be average, it can be complex. So these 3 forms of Kokomo, first is the basic Kokomo, which is the macro estimation actually, which gives an initial rough estimate of man months. Man months is the effort and the development time. How many people, how many effort with respect to and development time. So then we come to the intermediate Kokomo. First, the project is basic, it is small, and if we go up to the medium sized project, intermediate Kokomo, which gives us more detailed estimate of it. Finally, we have detailed Kokomo, which is the micro estimation, which gives a more detailed estimate, especially for the large projects, the complex projects. Basic Kokomo model. So the basic Kokomo model gives us an appropriate estimate of the project parameters. Kokomo is the constructive cost model. So what is the estimation? That is the time span of the project, how much effort we are going to put or need to be put, and finally the dollar, that is the cost of the project. And then the basic Kokomo estimation model, there is an expression, and this expression has empirically been suggested. So effort is A1 plus kilo line of code, KLOC, to the power A2. This will come in person month. Always remember, the unit of effort is person month. 1 person, 1 month, how much work. And once you found the effort, then we can estimate the time. The time expression is, time to development is B1 into effort to the power of B2, and this will come in months. Please remember, in months. Now this KLOC is the estimated size of the software product expressed in kilo lines of code. If it is 3000, you have to divide it by 1000. Okay, kilo line of code, and now we also call it as KDSI, that is kilo delivered source instructions. So these are almost same thing, just a bit difference. A1, A2, B1, B2, these are constant for different category of software products. There are three categories. One is organic, the second one is semi-detached, the third one is embedded. So the question will give you, or the project will tell you what kind of project it is. And depending upon that, you are going to use the A1, A2, B1, B2 value. T development is expressed in months. This is the time to develop. And finally, the effort, the total effort required to develop the software product. And this is expressed in PM or person month. Let us take an example. Now, assume that the size of the organic type, so the project type or type is organic type, has been estimated 32,000 line of code. Average salary for engineers is 15,000 per month. We have to determine the effort and the time. So how do we find it? We will use the, first of all, this is the table you need to remember. Organic type is there. If it is organic type, the effort and time expression is already given. This 2.4 and 1.05 are A1, A2, and 2.5 and 0.38 are B1, B2. Now effort expression is, let me write it again, A1 plus kilo line of code. Sometimes you are given the function points, so you can use function points also. So KLOC, kilo line of code, to the power A2. What is A1? 2.4 for organic. A2 for organic is a 1.05. And what is the kilo line of code? To the A1, A2 constant. 32,000 is the line of code. But this is kilo line of code. So 32,000 you have to divide by 1000. So you get 32. 32 KLOC. Now when you put these value into this expression, 2.4 plus 32 to the power 1.05, you will get 91 person month. This is the effort, okay, per month. Then time to development. So we have an expression B1 into effort to the power of B2. Remember, effort we just found out, we computed, to the power B2. This will come in months, not in year, months. Now in order to get the time development, just put effort here. Now you see for organic what is in the table. What is B1 and B2? B1 is 2.5, B2 is 0.38. These are fixed values for the basic Kokomo. When you compute this, you're going to get 14 months. That is 1 year, 2 months. What will be the cost required to develop the product? See, 14 months are there. Every month you have to pay 15,000. So what will be there? 14 into 15,000. So that will be the cost required to develop the product is 2,10,000. Intermediate Kokomo model. Now in this intermediate Kokomo model, the basic core of Kokomo remains the same. Only because of the change in technology and other aspects which has come. One more aspect, which is EAF. This is the adjustment factor that has been added here or multiplied here. Okay, so the same basic equation for the Kokomo basic model is used. But 15 cost drivers, these are rated on a scale of very low to very high. See, these are 15 parameters and very low to very high. To calculate the specific effort multiplier, and each of them returns an adjustment factor, which multiplied, it will yield the total effort adjustment factor. For example, you say that my software require a lot of reliability, strong reliability. So you are going to take, say, very high reliability. You are going to take this one, required software reliability. This is the product attribute, cost driver. So if you want very high reliability for your project, you will take the value as 1.40 in EAF. If there are multiple values you have to take in your project, if it is required, then you will take all the values and multiply it to get the EAF. It is simply the multiplication of these value being taken. In addition to this EAF, the model parameter A, this has slightly changed from the basic Kokomo model. Basic model, the values has been changed, but the parameter B is similar. So let me just show you again, because I have to show you the equation. This was the basic Kokomo equation. Okay, for effort and time development. This one A1, A2, B1, B2. But in the second part of basic Kokomo, that is the second version, which is the intermediate, only A and B are there. A remains same, A is slightly changed, B remains the same. Okay, now the question is database system for an office automation project. The project is simply given as organic. A value is already provided to you as 3.2. B already provided 1.05. C is also there, 0.38. Now 4 modules to be implemented. What are these modules? Data entry 0.6 kilo data. This the delivered software instructions we are talking about. Data update, query, report generator, all these are there. But the system size is also given 3. Okay. Now what you are going to do here is, see, the cost drivers, the level and EAF is already given. If it is not given, you have to use the table. That if it is complexity is required, to high level storage, to high level experience, to low level and programming capabilities or programmer capabilities, to low level, this EAF has to be used. These are value. I showed you the table. So these are the value, and this will be corresponding to or will be coordinated with the EAF, adjustment factor, effort adjustment factor. Okay. Now this is the expression of the intermediate Kokomo. E equals A KLOC to the power B multiplied by the EAF. This is effort adjustment factor. So what are the values of A and B? The value of A is slightly changed. The value of B remains the same. Okay. So since this project is organic, the time is like this. This time value is 2.5, which is the B1, and power is B2, which is different values. Okay. Sometimes in various books you will see this MMKORR. Don't worry, this is nothing but the effort. Sometimes you will see LOC, line of code. Somewhere you will see KDSI, that is the delivered software instructions. But the basic idea remains the same. Now these are the EAFs. These are the EAFs value. What you have to do, you just take them, multiply them together. Multiply all of them. Then you use the expression. So this is EAF already used. Now you have to put A here. We are just multiplying all of these, and this will come to 1.61 when we multiply all of this. 3.2 is already given in the question, and in the table also you see A is 3.2 for organic. What is the kilo line of code? See, the system size is 3 KDSI. So whether KDSI or KLOC, you are going to put it here, 3. And then what is the B value, the power B value for organic? It's given in the question also. You can use it here also, 1.05. So in organic, A will be 3.2, B will be 1.05. Put this in the expression here. What do you get? 3 raised to the power 1.05 will give you the value of 3.17. So you have this whole value is 1.61. 3.2 is already there. 3 raised to the power 1.05 is 3.17. And when you multiply all of these, you will get 16.33 MMKORR. Sometimes it is called as effort. Now let us come to the time of development. Now this is organic and you already have the table. So this is 2.5 E, effort raised to the power 0.38. Effort we just found out to be 16.33. So you have 2.5 multiplied by 16.33 effort raised to the power 0.38. And when you put it, you will get 7.23. And since it comes in months, so it is just over 7 months. Just over 7 months, or 7 months and a quarter of a month. Now how many people should be hired? And for that, this is very simple division. You divide the effort and the divisor will be time of development. So 16.33 divided by 7.23, which is the effort divided by the time of development, and that is going to give you the number of team members. So when you do 16.33 divided by 7.23, you will get 2.26. So it has to be greater than 2 team members, so around 3 members you will need.